Alright, you guys. So for the 14th day, we had to do a sand simulation. In my opinion, it was really interesting to try to solve. So for the input, we had a lot of points that described the cave walls because we were in a cave and we were trying to escape the sand. I mean, there was some sand that was dropping from a spot, and we were trying to see where the sand will end up after a couple of rounds of simulation. So we used our handheld device to do the scanning and got all the points, and on the map we can see with the hash symbol the walls of the cave, and with this small plus at the top, this is the spawn point of the sand. So over time the sand will drop from the top, and the rules for how it moves is that it always tries to move downwards, but if the spot right below it it's occupied, it tries to move diagonally to the left, but again, if that's occupied, it tries to move diagonally to the right. So it will form some sort of a pyramid at some point. And the main idea is that at first we think that the cave is bottomless, so it's like it goes down to infinity, so the sand will at some point drop and it won't stick to anything, it will just fall. So the question is how many units of sand will fall until that happens. So how much sand it will be in the cave at the end of the simulation. But then for the second part, like we are sitting on the bottom, so we didn't realize that, but there's actually a floor that we are standing on, so the sand will stop at that position, and it will build up. I guess it will build up a lot, like there will be a lot of sand. So question is how much sand will drop until the spawn point is stopped, it cannot drop sand anymore. So pretty much my idea was to simulate the entire thing and then count all the points that are made of sand. So I use this structure point, and pretty much I used it for both the input and for the simulation. So for the input we had those numbers separated by commas and by arrows. So the from string trait will, for the point, will receive two numbers separated by comma, and it will parse them into a point. Then I have some util functions for point, for example span, which will create a range from one point to the other, and yeah, pretty much this will be used to create the walls. So I'll give it the first point of the wall and the second point of the wall in, and it will create all the points between the two connections. Then I used this just for the input, this line structure. It separates the line using the arrow, and then it parses the results into a list of points. Then I implemented this into vec of point for line. Basically this will take a line that's the list of connections of corners of the cave, and it will apply the span function, as I said, between each pair of points, and it will create a vec of the walls, basically of each piece of the wall. Yeah, then parsing the input is just reading all the lines as line. Then just to be able to also visualize the problem, I created a wall structure, and I kept the rocks and the sands as hash sets. Then I also have this implementation of from vec of lines to world. Basically, if we get the input from the file as a vec of lines, we want to be able to generate the world. So first we convert all the lines into rocks, like into pieces of stone that make up the cave, and then we add to this hash map, or I mean hash set, we add all the points, and we create a world using only the rocks. Basically the sand in the beginning will be an empty hash set. Then I have this to string implementation for world. It will just display the world as a metric of characters, so it will use the hash symbol if the xy position is in the rocks hash set, and it will use an O character if the XY position is in the sans hash set. Then I use this plus for the 0500 position, and yeah, just return a string so we can visualize it. Then for the first part, I guess the spawning works differently for each part. So I mean, I guess the spawn works the same for each part, but some of the stopping conditions of the simulation work differently. So here I just spawned a point at the 500 position where it says in the problem that the sand spawns. Then I use this max y variable to keep track of the lowest point sand can reach. After that point it will just fall to infinity, and we will want to stop the entire simulation when that happens to get the solution for to get the answer for the first part. So if a sand reaches that point, we just return a none, and that means that we'll have to stop. Otherwise, if the sand grain can move one step down, we move it one step down. If not, we try to move it to left diagonally, and if that doesn't work, we try to move it to the right diagonally. And again, if nothing works, it means that the sand stopped on hard surface, it didn't fall to infinity, so we can return its position and also update the sand's hash set so that we know that we have something in that place. Then to get the solution, I just created the world structure, and then I simulated the first type of spawn until we got an unknown value, and I just returned the number of elements in the sand's hash set. For the second part, the only different thing is that the sand will no longer fall until infinity. It will just stop when it reaches this maximum y plus 2 value, which is the bottom of the cave where we are standing. And yeah, as I said, instead of returning a none value here, we just insert the sand and return its position. And then we do the same thing as before. We move the sand one step down, one step to the left, or one step to the right. And yeah, if nothing works, it means that the sand stops. So to get the answer for the second part, we simulate the second type of spawn again until while we get some point. And if that point is the spawn point, then it means that we filled the entire cave with sand. I mean, not really the entire cave, but basically the opening that was dropping sand was blocked, and we cannot get any sand in the cave anymore. So I guess we can stop the simulation and return again the number of points in the hash set. So yeah, I guess we can also try and visualize how the world will look after we drop all the sand. So this would be the first part for my input. You can see that it filled all these chambers, then it started to fall down to the next levels, and yeah, pretty much until it got to and it fell to like infinity, I guess. And then for the second part, I didn't show all the input because it was getting very large on the width axis, I guess on the x-axis. So it will look like the first input, but this time it will be much more sand, but it still won't be able to fill all these spots because I guess they are unreachable for the sand. And yeah, I mean, I guess it looks like nice patterns, so that's cool. And yeah, I guess simulating the entire game takes a bit of time. For the second part, it takes like 5 or 10 seconds to do everything, but yeah, I mean, it's worth it, I guess. So yeah, this was the 14th day, and I really like to be able to visualize the simulation. And if you also want to try out the code or modify it, you can find it on my GitHub and check it out. And as always, I'll see you guys next time.